Hello friends, welcome to Basic Electrical YouTube channel. So in this lecture, we are studying about obtaining the expression for power factor in terms of wattmeter readings. So in previous lecture, by using 2 wattmeter method, we calculated what is the power consumption for both star connected as well as delta connected. From that we got to know the concept whether star connected or delta connected power measurement will be same. By using 2 wattmeter method, what is the equation of power we got? Root 3 VLIL cos pi. Okay, that formula is valid for both star as well as delta connected load. Now this topic is required only to solve problems on wattmeter readings. If I know the wattmeter readings W1 and W2, from the wattmeter readings we can calculate power factor of the star connected or delta connected load. Those wattmeters used to measure power consumed by the either star or delta connected load. So very important topic only for problems. So theory they won't ask the question on this particular topic. However, if they ask also, it will be very easy. Students can easily write it. Let's start with this topic. Obtain the expression for power factor in terms of wattmeter readings. So we know that for a lagging power factor load, why I taken lagging power factor means, see, measurement of 3-phase power by 2 wattmeter method. Okay, I got the W1 readings VLIL cos 30 minus pi, and W2 reading I got VLIL cos 30 plus pi. I got that readings assuming the load is inductive. Okay, so I am taking the same readings. Inductive means lagging power factor load. So from the for the lagging power factor load, we got wattmeter readings. W1 is what? VLIL into cos 30 minus pi, and W2 reading is VLIL into cos, very good, 30 plus pi, cos 30 plus pi. So by adding these two wattmeter readings, if I add the wattmeter readings W1 plus W2, so what we got? We got 3-phase power measured. That is root 3 times of VLIL into cos pi. How we got this equation? You see the previous lecture. You apply cos A minus B and cos A plus B formula, simplify by adding these two readings, and the end you will get this equation. So this is what total power consumed by the load when we measure power by using 2 wattmeter method. So take this equation number 1. Similarly, subtract 2 wattmeter readings. Okay, first case, add 2 wattmeter readings, then we get this equation. Now subtract the 2 wattmeter readings. So what we get, we can simplify that. Okay, this one we done in the previous lecture, so that's why I wrote directly. Now we can do this one. So VLIL, W1 is VLIL cos 30 minus pi, okay, W1 reading, minus W2 VL into IL cos 30 plus pi. Apply cos A minus B formula. So by applying cos A minus B formula, we can write VLIL, this is A value and this will be B value. This is A and this is B value. Apply cos A minus B formula. Cos A minus B formula is cos A cos B, okay, plus sin A sin B. Okay, I applied the formula. Then minus VL into IL. Now apply cos A plus B formula. Cos A plus B formula. What is the cos A plus B formula? Very good. Cos A cos B minus sin A sin B. So cos A cos B minus sin A sin B minus sin A sin B. Now simplify this two. So this becomes VLIL into cos 30 into cos pi plus VLIL into sin 30 into sin pi minus into this minus VL IL into cos 30 into cos pi minus into minus plus VL IL into sin 30 sin pi. Now from this we can cancel this first term. Plus VLIL cos 30 cos pi gone. Minus VLIL cos 30 cos pi gone. So what is left now? VLIL sin 30 sin pi. VLIL sin 30 sin pi becomes what? Very good. 2 times of VLIL sin 30 into sin pi. So now 2 times of VL into IL. What is the value of sin 30? 1 by 2, half. Okay, 1 divided by 2 into sin pi. 2 get cancelled. So finally, by subtracting 2 wattmeter readings, what is the equation we got? VL IL into sin pi. So this one you can take it as equation number 2. So by subtracting 2 wattmeter readings, we got this expression. Same thing, if I add the 2 readings, W1 plus W2, put plus here, simplify, then you will get this equation. Okay, refer previous lecture if you need means. Okay, now after finding this, now divide equation 2 by equation 1. So divide second equation by first equation. Okay, why means I will tell later. So now numerator, okay, second equation. What is second equation? W1 minus W2. So W1 minus W2 is equal to, okay, what we got that equation? VL into IL into sin pi divided by equation 1. What is equation 1? W1 plus W2. W1 plus W2 is equal to, what is that formula? Root 3 VLIL cos pi. Very good. Root 3 VLIL into cos pi. Now we can cancel these terms. VL get cancelled. IL get cancelled. Okay. Now what is sin by cos? Tan pi. To get tan pi relation, that's why I divided equation 2 by equation 1. So if you retain equation 1 divided by 2 means, then cos by side you should write some other relation. So let's go with standard relation, tan pi. So now further, W1 minus W2 divided by W1 plus W2 is equal to sin by cos is tan pi all divided by, what is the denominator is left? Root 3. Tan pi by root 3. Now from this step, you write expression for tan pi. See, I am going to write after this, I am writing here. Okay. Tan pi can be written as, tan pi is equal to root 3 times of W1 minus W2 divided by W1 plus W2. Okay, got it? Just cross multiply. So now from this we can write pi can be written as tan inverse of root 3 times of W1 minus W2 divided by W1 plus W2. Okay, this is the phase angle value. Tan inverse of this equation gives pi value. Now we know that power factor. What is power factor? Cos pi. Okay. Now I am writing here cos. Now here pi is replaced by this equation. Whatever you wrote here, replace that pi by in this equation. Okay. Pi can be written like this. Tan inverse root 3 within the bracket W1 minus W2 divided by W1 plus W2. So this is the final expression for power factor in terms of wattmeter readings. Okay. See, if you know this formula, so in question, in problems they will ask, they will give 2 wattmeter readings, W1 value and W2 value. Substitute that wattmeter readings here, then you can easily find power factor of the load. Okay, got it? So this formula is very important for solving problems. Understood? So please pause the video and then copy down whatever I wrote. So it is, remember this formula. Okay, very easy. They won't ask in exam theory. Problems, we need this formula. Okay, how we got that formula? That was I explained. Okay. So guys, in next lecture, we can study the effect of this power factor based on the wattmeter readings. If I change the wattmeter readings, okay, then what is the effect on power factor? Okay, that is our next topic. So that is required, that topic is required to understand the subject much better. Okay, and from that we can easily solve problems. Okay, in a confident manner. Okay guys, have a nice day. So please like this video and share to your friends and tell your friends to become a member to watch the video content. Okay guys, meet you on next lecture. What happens if I change the wattmeter readings on the power factor? So that is effect of wattmeter readings on power factor. Okay.